Okay. Okay, let's get back to work. Hello? Okay, so for those of you that are not here, I'll just record it, and otherwise we're moving on. Okay, so we were at the logistic growth before the fires started, and I said that the logistic growth formula looks something like this. Okay, x dot rx 1 minus x over k, rk constants. Okay, and the first step I said was identify which are your f and g's. Okay, and this is a particular case where f of t is just 1. What does f of t equals 1 mean? It means there's no t here. There's only x's here. So my g of x is just the whole thing. Rx multiplied by 1 minus x over k. Okay. A way to check if you did the split or the identification correct is f of t has no x's, g of x has no t's. So it's okay. Now we just follow the steps again. I'm looking, so the first step is look constant solutions. Okay. Same thing. What are the constant solutions? It's g of x is equal to 0. Okay. Now, I'm replacing. It means that r multiplied by x multiplied by 1 over x over k is equal to 0. Okay. Now, the first case is x equals 0. Okay. Do not divide by x automatically. And the second case is that the parentheses is 0. 1 minus x over k is equal to 0. So x is equal to k. Okay. So again, I'm looking for constant solutions, and I'm just making my g of x is equal to 0. Got the constant solutions. Okay. And just the way of phrasing, the way you phrase is two solutions up to this point. Solutions which are x of t is equal to 0 for all t in R. And you don't need to write this again, but I just write it in order to be complete. And x of t is equal to k. Okay, same thing if you want to write it. Okay, now I move to the second part, which is actually solving it. Solving it by separating them. Okay, and your function was x dot is equal to rx 1 minus x over k. How do I separate? I just move everything that depends on x on the left side. So I get x dot over x 1 minus xk is equal to r. Okay. And again, this is just equal to integral of 1 x1 minus xk dx is equal to integral r dt. Okay. Again, you could have used the formula. That's fine. I don't care. But what formula am I talking about? It was that integral of 1 over f of g of x dx is equal to integral of f of t dt. Okay, you could have just used the formula and replaced with, replaced with f of t is equal to 1 and g of x is equal to the whole thing. Okay. Now, observation. up here, when I did the identification, I could have moved the R up top or move it down below. Doesn't matter at all. R is a constant, okay? When you're dealing with constants, doesn't matter if you put it in f of t or g of x. The constant does not depend on t or x. Does that make sense? Okay, so it doesn't matter where you put it. Okay, so I got this equation over here, and I need to solve it. I'm going to use the hint, just like you should in the exams, but I'm going to give you another discussion about this. The hint is that 1 over x, 1 over x over k is equal to 1 over x plus 1 over k minus x. Okay? That's just the hint. Hint given by the problem. And now the question is, can I use this? Well, this was my equation. And they're basically telling me, hey, we can write that fraction as this thing. So sure, I'll use it. Why not? So I get integral. My equation, I'll just write it here so we have it on the same page. K 1 minus x, sorry about that. This is x. 1 over x over k. dx is equal to integral r dt. I just wrote it as the same formula, but I had to write it since it was on a different page. Okay, now I got this, and I'm going to use the formula up top. So I just replace integral 1 over x plus 1 over k minus x, everything dx. And as I said, r is a constant, so what is it equal to? How do I get r? What is this integral equal to? It's just t multiplied by r plus a constant. Okay. Now, I just solved this like I would solve any normal integral. So I split it 1x dx plus integral 1 k minus x dx is equal to this t multiplied by r plus constant. Now, what is this? That's just log of x. And again, observation here. I would just simplify your work, I guess. If you want to be thorough, you can do it, but it simplifies a lot. You can write log of x plus a constant, okay, plus constant 1, plus constant 2, whatever. But if you already have the constant here, this c over here, you don't need to write it here because they're just going to cancel out, okay? So I'm just going to write the antiderivative, which is this log of x plus, what is the antiderivative of this? Again, I think there's a formula in the book. It's minus log of k minus x, okay, is equal to tr plus a constant. Again, I did not write the constants anymore because I have a constant on the right, and it's going to be exactly the same thing. So I don't need to care about that. Okay. Now, this is just equal to log of x minus log of k minus x is equal to tr plus a constant. Okay, now I'm just going to use some log formulas. Which is log of, again, this is module, but let's just assume for the simplicity that k is always bigger than x. Okay, for simplicity here, since I think I'm going to get hit with the question, what if this is negative? So I'm just going to say k is greater than x for everything. Okay, just leave it at that, or I'm only going to look at that case. Okay, so using the formula, log of a minus log of b is equal to log of a over b. Okay, this is the formula I'm going to use. And I apply it right here, and I get that log of x over k minus x is equal to t multiplied by r plus a constant. Okay, now what is this? What does log mean? It means that x over k minus x is equal to e to tr plus a constant. Again, the only formula I used here or whatever is, you know, if log of a is equal to b, then e to the power of b gives me a. Okay, this is again the definition of taking a log, I guess. Okay, so I got this. And now I just gotta make this, get the x out of here. Okay, it's literally all I have left to do. So I have x k minus x is equal to e t multiplied by r plus a constant. I multiply everything with k minus x, and I get x is equal to e t multiplied by r plus a constant multiplied by k minus x. Okay. So I have x is equal to e t minus r plus constant multiplied by k minus e t multiplied by r plus a constant multiplied by x. Okay. Now I can just move everything with x on the other side, and I get x 1 plus e this thing t multiplied by r plus a constant is equal to e t multiplied by r plus a constant multiplied by k. So x is just equal to 1 plus e t multiplied by r constant over e, yeah, up top this thing. Okay, e t r plus k plus c multiplied by k. Okay. Now, if you want to be a little bit more fancy, I mean, not fancy, just it's exactly the same thing, literally the same exact thing. But I can just write everything as e t r multiplied by e to the power of constant multiplied by k, 1 plus e t r multiplied by e to the power of constant. And I just say this is going to be my new constant. So I just write it as x of t, the final answer, is equal to e t multiplied by r multiplied by a constant multiplied by k is equal to 1 plus e t r multiplied by a constant. Okay, and this is my final answer for case 2. When you're giving the results, be careful to also write the other two, the ones that we solved, the constant ones, which was xt is equal to 0 and x of t is equal to k. All right, so these are the 3 things you needed to find out for this problem. Any questions up to this point? Okay. Now, again, if I told you if I phrase the question something like find the particular solution such that x I don't know, x 2021 is equal to 2022, what would you do? If I just phrase it like this, you would just literally replace t here and get the constant out. Okay, not planning on doing that. It's just a matter of knowing what to do when you're faced with stuff. Okay. Yeah, so any questions on this example? Anything that I did that seems spooky or it makes sense? Okay. Now I guess we can just do some problems that were actually given at the exam. Some of the exams, I guess. Okay, so let's just do, I think this is exam 2018, 2019, one of the two, I don't remember. And it's problem 2. Okay, from 2017, I guess. Okay, in case you want to look at it. All right, so I'm just going to show you that basically it is as simple as I'm trying to do it. And just don't panic. So the first part, A, has nothing to do with differential equations, just some limits, so not planning on doing. B asks you to find P and Q such that, and I'll write this integral since we are going to use it, okay? Integral of t to the e minus 1 log of e squared. I know it's a horrible integral. T e minus 1, it actually gets better if you compute it, but dt is equal to, I don't know, t to the power of e q plus log of t plus a constant. Again, you don't need to understand, you just need to know that this is it. Okay, so you're asked to find the constants of this. And the most important part that I'm trying to claim here is, even if you didn't solve B, okay? If you didn't solve it, you can still use B on C, D, E, F, G, okay? So really, really important, because now when I'm asked to find the general solution of the differential equation, x dot of t is equal to t e minus 1 log of e squared t e minus 1 multiplied by x squared. Okay, you're asked to solve this differential equation. And it might look ugly. It might look ugly and you might get lost, but if you just take it step by step with the notations and everything, it's going to be just fine. What do I mean by this? Well, again, how I would solve it. X dot of t is equal to f of t multiplied by g of x. Okay, identify my stuff. So my f of t is equal to everything that has a t in it. So this whole thing has a t in it. So just t e minus 1 log e squared t e minus 1. Okay, and my g of x is equal to x squared. Cool. I just basically did the simplest thing I can. Now, either you use the formula automatically, which is integral of 1 over gx dx is equal to integral f of t dt. You either use this, or again, you move everything with x on the other side, etc., etc. I'm gonna just use this for now. Okay. Unless you guys want me to just move it, it's one intermediate step where I just write I just move this circle, the x squared on the other side. So I don't think it's really necessary. But again, I'm just going to replace now. I have integral of 1 x squared dx, okay? Because my gx is x squared, so I just replaced it, is equal to integral of t e minus 1 log of e squared t e minus 1 dt. Okay? And at this point, you might say, well, how am I supposed to compute this? Okay, it looks horrible. And this is what I'm trying to say. Use everything that the problem tells you. Like, you can use part B, okay, which part B basically tells you what the integral is equal to. Even if you didn't solve it, even if you don't know what P and Q are, the problem even says you are allowed to use P and Q. Okay, so don't be afraid to use B, C, or in D or E. Okay, it doesn't matter. So this is my thing. This is the thing I want to compute. And I know I know the fact that P multiplied by T e minus 1 log of E T minus 1 dt is equal to TE Q plus log of T. You literally copy it like a text. It doesn't matter to you, okay? You know this from point B. So what's stopping you from literally just replacing this integral with the value? And the answer is absolutely nothing. This is exactly how you're supposed to do it. Okay? So now, what's my answer? My answer is, you can look in your notes since I don't have the whole formula anymore, but it's 1x squared dx, which was my left side, is equal to, and I am just going to copy this thing divided by P. Literally just copy this thing divided by P. It's just equal to TE Q plus log of T plus a constant, everything divided by P. Okay, any questions what I did up to this point? Okay, now what if I take a derivative of, I get 1 over x squared, okay? You can use the power function or whatever. I'm gonna tell you it's minus 1 over x, okay? So minus 1 over x is equal to TE Q plus log of T plus constant over P. So what is my x of T equal to? Again, just flip everything. X of T is equal to minus P over TE Q log of T plus a constant. Yeah. Any questions? And this is all the problem. At this point, you're done. Even if you, that's my point, even if you don't find it, you are allowed to use this. Even if you don't find P and Q, like the way I wrote it is literally full point, almost full points. I did it on purpose, but you guys missed it. I thought you would stop it, but you kind of you didn't. So, but yes, this, if you write this is 100% correct, even if you have P and Q as it is. It doesn't matter. You don't need to compute it. You just need to use the fact. If you find an interesting relationship or you want to use something that was in a previous point, even if you didn't prove it, feel free to use it. If you use it successfully here, you're going to get maximum points. The only reason, if I would just write everything that I wrote up to now, the only reason I would not get full points is because I did not check for a constant solution. Okay. And this is a mistake that 95% of you make, and you'd have, I trusted you, but you let me down, guys. I thought you'd stop me. So again, the first step is checking for the constant solution, okay? Check constant solution. That was step 1. Solution, okay? What does this mean? It means g of x is equal to 0. What was my g of x? It was x squared. So x squared is equal to 0, means x is 0. So I have found the solution, x of t is equal to 0. Now, this plus the thing above is full score. Okay. Realistically, if the grader sees you got both solutions, he's not even going to check more or less what you did in between. So Again, any questions on how I solve this? Does it look hard if you follow the blueprint? In order to get full points on what was in this year the hardest problem, I think, because people didn't realize they could use D. Okay. Now, I'm gonna give you another example because I think that this type of problem actually comes up more or less every year. So let's take another example. Oh, we have time. Yeah, we have time. Let me look. Yeah, this looks fine. Okay, cool. So again, it's any questions here? What I did. Okay, then let's just do problem number 2. So problem number 2 from exam 2019. No, I think it's 2018 fall. Anyway, still problem number 2, still exam a recent year. What is it? The first problem is in point A, you're asked to compute some limits, ... We're not going to solve it. We don't care about them right now. Then you're given in point B, you're given some integrals. Okay, show the following stuff. Show that integral from x to 1 is 1 over u multiplied by 1 minus log of u du is equal to log of 1 minus log of x, where x is greater than 0, smaller than e. And in case you're wondering, oh, why do I need the exam? You can't, because you can just prove it by taking the derivative. No, you can't. And it's because of me, because I kind of told everyone that, hey, you can just take the derivative of the right side. He's now writing in the exams, show by anti-differentiation. Okay, so you're not allowed to show by derivation. So I'm responsible for that, to change that. I'm sorry for you guys. You're probably not gonna be able to show this by differentiation. If he doesn't, if he makes a mistake and even wrote, there is no score for differentiating right hand side. So I'm surprised they didn't write my name. Anyway, moving on. So if he doesn't write anything like this, you're free to differentiate. If he does, that is what it is. Okay, so then you're given, show the next thing, that is e to the v multiplied by log of 1 plus e v everything squared dv is equal to, and he gives you the formula, 1 plus ev. Again, I'm just copying the form. We're not planning on proving them by any means. Okay. Minus 1 plus a constant. Okay. So in point B, you're asked to show these. If you manage to show them, good. If you don't manage to show them, remember, you can still use them. Yes.
What did you say? Log of c times right hand side.
It's 1 plus e to the power. It's log of, no, it's a double parenthesis. It's supposed to be a double parenthesis here. It's supposed to be a double parenthesis. Yeah, sorry. Yeah, is equal to this thing. Okay, you prove it, you don't prove it. That is what it is. But then you can use that in point C, which asks you find the general solution of the differential equation for x in 0e. Find the solution to x dot is equal to, and again, you shouldn't get intimidated. He might give you the like long 10 million word and formula long differential equations. They all solve the same exact way, like literally the same exact way. The start is the same, and I doubt he's gonna ask you for anything else. Okay, you're asked to solve this. first step, take a deep breath. Don't panic. It looks absolutely ugly, but you know, x dot is equal to f of t multiplied by g of x. This is all you know, so this is what you do. You identify, and you get f of t is equal to e to the power of t log of double parentheses 1 plus e t squared, everything here. And g of x is equal to x1 minus log of x. Okay, cool. Now, let's not mess it up this time. First check is check constant solutions. Okay, what does this mean? It means g of x is equal to 0. What does this mean? It means x, just replacing 1 minus log of x is equal to 0. Now, two cases. X is equal to 0. Second case, 1 minus log of x is equal to 0, in which case x is equal to e. And be careful, it seems like we found two solutions, but remember, he said x is in 0e. Okay, so again, just a kind of a trick. It's like you found the two constant, and they would in all parallel universes be the correct constant solutions. But in this case, he just said, hey, x is just in this interval. Okay, so you found these, but x is in 0e. Okay, so if it's inside this and it's open, it means x cannot be e or 0, so no constant solutions. Okay, but it's always important to check. Now, once we got past this trick, we're gonna move on next, which is again, either use the formula. What's the formula? Integral 1 over f of g of x dx is equal to integral f of t dt. Either do this, either use the formula, or just move everything on the other side and integrate. I'm just gonna use the formula since I kind of memorized it myself by now. So remember, g of x is x1 minus log of x. F of t is equal e t log of 1 plus e squared, everything the power of, no, it's t here, everything the power of square, whatever it is. Okay, cool. Now what do? We just replace integral of 1 over x 1 minus log of x dx is equal to integral e t log of 1 plus e to the power of t, everything squared dt. Okay, cool. Now, yeah, now what? Well, you're stuck for a little bit, but then you just look at point B. And you compare, I don't know how to make it. Okay. Let's look at this thing. Okay. Does it look familiar with anything? Maybe this? Okay, it's literally the same exact. So what you do is you just use point B. Even if you haven't showed point B, again, it doesn't matter if you showed it or not. You just use it. Be an opportunist, I think it's called. So why not? Again, I'm looking here, I notice that I have the same thing and I'll write it here. From point B, I know that a half integral of EV log of 1 plus e to the t of v, everything squared, d of v is equal to 1 plus ev. And again, I'm copying this for no particular reason. You don't need to copy it. You just need to say from point V, but I'm just showing you that it's convincing you that it's the exact same thing. Okay, it's the exact same thing. Well, without the half. Okay, without the half. Cool. Now, so I know. So do you guys agree that I know what the right side is? Okay, we know what the right side of this thing is. It's just this thing replaced. Now let's look at the other. We had still in point B, we had integral of x1 u1 minus log of u du is equal to log of 1 minus log of x. Okay, cool. Now, you know, in this case, you might get a little bit stuck because you're looking at this and you're thinking, hey, this is a definite integral, right, from x to 1. So maybe it's not what it is. But you can have the idea of taking a derivative of this and seeing where you get. Okay, so let's just see if I take a derivative, what happens. Let's just see. So I'm just going to take a derivative. Derivative of log of 1 minus log of u with respect to u. Okay, I'm just computing this derivative and I'm seeing what it is. I mean, so there are two choices. Either you can compute them by yourself, or you're fishing for the result because you're looking at your problem and you're saying to yourself, hey, these two are too similar. They can't just be given for nothing. Okay, the professor is basically telling me, hey, use this somehow. So I'm just going to take a derivative of this and see what happens. If I take a derivative of this, I'm just going to get, again, the chain rule. F of g of x derivative, if I take a derivative of x, I'm just writing the chain rule in case you forgot it, but it's f prime g of x multiplied by g prime of x. Okay, so applying here, the same thing. Log derivative of log is just 1 over that stuff. So it's just 1 over 1 minus log of u multiplied by 1 over u. This is log of, sorry, I messed up. This is minus 1. This is 1 minus log of u derivative. I'm basically taking the derivative of what's inside, so g of x. And this is just log derivative here of 1 minus log of u. Okay, makes sense? Everyone followed on this derivation? Okay, so now this is just equal to minus 1 over u multiplied by 1 minus log of u. So I'm looking at what I have to get. So it seems like the answer was there. Okay, it seems like this is what I wanted to get. This is what I got. It seems like everything is okay. So using this thing over here that I just computed, what is the integral of x1 minus log of x dx? Well, it's the inverse of differentiation. So if I got here by differentiating, I just go back by integrating. So it's just minus log of 1 minus log of x plus a constant. Did that make sense? Did you guys follow me doing that? Cool. Well, again, now my problem is done. I'm done with the whole problem. Why? Well, I was here. And using point B, I managed to solve both parts. So I just replace, get my x out, write the x nicely, and I'm done. So gonna replace with this. You can check, you can follow me in your notes. I'm just gonna skip page. So I've got minus log of 1 minus log of x. Again, no point in carrying the constant both sides, so I'm gonna leave it as it is equal to, and now I copy, so I copy this for the left side, and now for the right side, I just copy this. This is just equal to 2 multiplied by, and I'm just gonna copy. It's 1 plus, you can follow me in your notes or everywhere, I'm just copying. 1 e to the power of t log of 1 plus e to the power of t minus 1 plus a constant. Okay, so now all I have to do is get my x out and I'm done. So this is just log of 1 minus log of x is equal to minus 2 multiplied by the whole shebang. Okay, so again, using the formula, log of a is equal to b. This means that b, let's make the same b to the e to the power of b is equal to a. So it means that 1 minus log of x is equal to e to the power of all this horrible stuff. And again, you don't need to panic. You don't really care what's here. You just copy it like you'd copy a text, a wall of text. Okay. And now I only have to get x out. So move x to the other side, and I get log of x is equal to e to 1 minus e. And again, just copy everything. There's no work being done here. I have no intention of doing anything here. Plus a constant. And again, using this formula here, I get x of t is equal to e to the 1 minus e to everything here, okay? I know it looks absolutely horrible, but you're lucky that you don't care. You actually don't care what's here, okay? Now this is a constant, so can you just pop it down? Yes, I'll just leave it there because I'm lazy and I don't need to do it. But this is your final answer. You're done. Yeah, and I guess I could give you other examples from the other years, which are basically the same exact thing. So I don't know, any questions on what I did? Probably these are the most recent years I could find, but let's see, I could maybe find like a previous one if you want. Otherwise, just questions on what I did. What I did in like simple language, I just applied the standard methods for solving a separable, and I sneaked my way using what the professor gave me in point B. You could technically have solved this even if you didn't know exactly how to solve an integral. Okay. Because he gave, I don't know, we can look 2016, I guess. I haven't looked at them, but I'm assuming it's going to be the exact same thing. Yeah. It's literally the same exact thing. I can write it for you guys just so you convince yourself. I don't know if I'll have time to prove it, but again, and I swear I didn't even look. Problem 2 from 2016. And yes, I'm fairly confident if I go to 2015, it's gonna be the same thing. Okay. You're given that M is a constant. And f of t is equal to t the minus 1 minus 1 minus m log of t log of t. So an absolutely beautiful function for you guys. And then what are you supposed to compute? In point A, you're again supposed to compute some limits. We don't care about that. In B, you're getting some changes, which some global minimum stuff. Again, we're not going to solve that. And then in point C, you're given some integrals. You're given you're having them in a, I guess, more hidden way because they use limits, but it's the same exact thing. It's they ask you to show that 2m limit of a equals 0 with a plus integral of a t f of t dt is equal to what is this? Minus 2m integral of t infinity f of t. Again, some horrible thing which you don't really need to solve in order to solve point C, which is what we are trying to learn right now. Minus m log of t. Okay, so this is what you have to prove. Again, if you don't do it, nobody cares. Now, in point D, which is the thing we're going to try to solve or do as much as we can as fast as possible. I mean, in point C and point D, I mean, you're asked for the general solutions to the following differential equations. And you have x dot is equal to f of t e to the power of x. Oh, sorry about that. Yeah, you have to show this, and then they give you a linear equation as well. Y dot is equal to f of t e to the power of t plus y. Okay, I'm not going to do the second one. The second one is basically just plugging in the formula. So I'm going to, and I believe you can just plug in the formula. Okay, so now in these cases, the professor even says, hint, use part C. It's literally in the exam, so feel free to use it. Again, let's do this. Let's do the first one. X dot is equal to, even in our notation, we have ft equal EFTG of x. So, f of t is equal to f of t. I know that doesn't say much, but g of x equal to e of x is equal to e to the power of x. First step, check constant. Okay, we check constant, and what does that mean? It means that g of x has to be equal to 0, which means that e of x has to be equal to 0, and x does not exist. So no constant solutions. Okay. And then in 2, I actually use the formula. What's my formula? 1 over gx dx is equal to integral f of t dt. You would imagine that after writing it so many times, I would actually remember it. Okay, cool. So now I just plug in my stuff and I get integral of 1 over e dx dx is equal to integral my f of t dt, which is, again, f of t is that ugly function. Okay, yeah, it's that ugly function where f of t is just equal to t to the -1 minus m ln t ln of t. Okay, this is your f of t, but it doesn't really matter since I'm just planning on using the formula that's there, which is, the formula is, this is from point C, limit when a goes to 0 with a plus of integral from a to t f of t dt is equal to minus t to the minus m ln t. Okay. And now we're going to do exactly like we did in the other part. I'm going to assume, hey, because this, this is like a limit of a definite integral. Mine is indefinite here. I would like indefinite, but still, I have the same form here. So it's natural to just think of what happens if I take a derivative of minus t minus m log of t with respect to t. It's just natural to see what happens, okay? And I'm not even going to compute it. My intuition says that you're going to get exactly f of t. I don't know. Let's see. Let's check the solutions. Yep. If you just take the derivative of that stuff, you're just going to get exactly f of t. And you're basically done at this point because we're going to do exactly the same thing. Replace this with the function. And yeah. But yeah, any questions? Because at this point, I think I'm just doing the same thing over and over again. But it's literally just the second problem on each of the exams. You can check them themselves. I'm not actually inventing this. So yeah, any questions for me? Any questions on any kind of differentiation? Any kind of anything, I guess. On the homework, differential equations will only be used in the last 2 parts. The second to last part is beyond trivial. It asks you to check for a particular solution. They give you the solution and ask you to check for it. So how do you check? You just replace in derivative, right? So it's done. And the last one, just in terms of differential equations, asks you whether you understood what a particular solution is or a constant solution is, which I hope you did. I hope you understood at least what a constant solution is. What does checking for a constant solution means? Okay, and you should have the last 2 parts. Everything that we did here afterwards is more than you're going to have on the hand-in, but it's might, as you can see, it might come up on the exam. Yeah. I don't know. Any questions? Otherwise, I think it's been an eventful day for all of us. We've been through fires, so I'm just gonna end it here. Yeah, and this is my last lecture. So thank you very much for coming. my mom asked something. So for those on Zoom, I'm sorry, but my mom asked like a kind of a Hollywood picture with all of you. So I'm gonna do right now. I'm sorry, please don't disappoint my mom. Okay. So I think I'm getting everyone. All right, thanks everyone.